All right, folks, welcome. And it is my pleasure to welcome back Jeff Carrell, who's a veteran here at the Tech Club presentations. I've been here a few times already. He's given us the Wireshark workshop before, and he's back to do it again. And this workshop is going to cover basics of Wireshark operations, setup and configuring for Wireshark for optimal use, and some tips concerning multiple profile configurations. Following the information that he provides for us, Jeff's going to give us some lab exercises, hands-on, in order to demonstrate the newly learned ease of use capabilities within Wireshark. So if you have Wireshark on your computer, please feel free to take part in that hands-on lab. If not, watch and hopefully take back some pointers. So just a little bit about Jeff. He's a networking big data instructor and course developer with Hewlett-Packard Enterprise, or HPE. He is a frequent industry speaker, a technical writer, IPv6 forum certified trainer, and was a network instructor and course developer for major networking manufacturers prior to working with HPE, and essentially is doing just that as well while working with HPE now. So everybody, welcome Jeff. Jeff, take it away.
Awesome. Well, thanks everybody for letting me come back and talk to you for a little bit of time, and hope everybody's doing well. And we really do thank you for taking time out of your schedule, whether it's evening or morning or afternoon, wherever you might be. Welcome. So as they say, definitely assuming that everything is sharing, even though I wasn't supposed to ask because I think you should be able to see, but I just wanted to make sure. So first thing I'm going to do is a boring PowerPoint presentation. I got about 200 slides to cover in 15 minutes, and that becomes a no, not really. But I'm going to do a few little PowerPoints just to kind of have some talking points. I'm also going to do some Wireshark demo, I'll say on my side with a trace, but if you go down to my GitHub site and go to that folder, the Wireshark workshop, there's a couple of traces that will be able to go through together, and that way I can do it, you can do it, kind of I call it the follow Jeff, or the follow me. I get a little bit more, but I want to show some of it first and then kind of maybe go through it together, because if you're not I would say a big or frequent user of Wireshark, and I truly find across the IT industry, there's a lot of people who say, yeah, I use it, or yes, I've used it, or I only use it when I have to, and I don't do much with it. I kind of fire it up, got a trace file, and maybe I just send a saved trace file to people. So one of the things, if you can find your icons, give me a hand raise or a yes if you use Wireshark, even if it's just every so often, once a month, maybe. It doesn't even have to be super frequent, just to kind of get an idea. I'm not going to say I make this something that everybody does, but I kind of think that most folks in the networking kind of vertical side of IT and into the security, which is I know broad, then folks might use it. And if not, that's okay too. But humbly, I would recommend pick it up, get a little bit more into the using of Wireshark. If nothing else, it just kind of helps validate some of the things that you might be looking at. If you're looking for certain either things on the wire, things that are going on, or what you're trying to maybe do a little bit of recon. Well, what's all out there to recon? It's one thing to get to the server, look at usernames and look at machine databases and all that other kind of stuff, but what are the packets doing? What are you seeing on the wire? And that's a little bit of what I want to kind of show in part of our time together here. So the GitHub site, go pick up some stuff there. Not necessarily a lot, but you can definitely have a little bit. So I'm going to go through the slides relatively quick, okay, just as some highlight points. Again, a quick view of some of, I'm going to call them the well-known ports. These are the basic protocols of the foundation applications that are possibly running around. We're not going to get into the nitty-gritty customized, but you need to humbly need to know what DNS is and what's the protocol and what the packet looks like, and some of the other management protocols, like whether you're going to have Telnet, SSH, file transfer protocols, network time. Um, why are some of these things important? Because they will give you an idea. They will give you the capability to start making that network diagram, making that map. Whether you write it down on paper or you draw it out on an application or you've got it in your head, just to get an idea of really what's going on, and maybe give you the ideas of where else you're trying to go from any, let's say, networking and security perspective. Are you troubleshooting applications that aren't working? Are you doing some sort of recon and you're just trying to find out what's there so that you can start working on a more detailed discovery as you go along? So just some, not all, but just some of the protocols. Quick little bit on the headers, all right? Knowing where we spend some of our time. I would say from some perspectives, you know, a lot of the time I spend is way up here into the destination, maybe, all right? But up in the upper part of the headers, maybe down into some of the options. Um, for me, in a lot of what I do, though, I don't spend much time in payload. That's not where I need to be for what I'm looking at. Now, if I'm troubleshooting an application, maybe a whole other story. But at least from some basics, that's kind of what I want to look at, is what's going on in the headers. What do I want to try to capture traffic on? In the mode of, I don't want to look at everything. I need to start looking at subsets. Similar to that in looking at an IPv6 header. Okay, so they're constructed differently, different bits of information in there, but largely the same type of information, maybe just in a different place. So understanding that sometimes. In working with Wireshark, you go get it. It's free. Now that's the first big thing we're supposed to really go yeehaw over, is that it's probably, you know, the best protocol analyzer, and it's completely free. It's the probably most successful global open source project. And it all started from one guy in Kansas City who was trying to look at packets. He was working at an ISP. His name is Gerald Coombs. And he couldn't get what he wanted from the varying other programs that were out there at the time. And probably the biggest one at the time was from a company called Network General. It was called the Sniffer. And he kind of didn't like it. You know, well, not that he didn't like it, he just couldn't get what he wanted. So he started working on his own thing, and he kind of shared it and moved around. He kind of finally named it. It was called Ethereal. Or if you're like me from Texas, you got to put a couple extra syllables in there. It's Etherreal. All right. In fact, I called it Etherreal until I met Gerald about 10 years ago and found out that I was mispronouncing it. But at the end, it didn't really matter. And in the earlier 2010s, it was renamed to Wireshark. So go get it, wireshark.org. And you can get it for just about any platform. And it's free. Oh, that's the cool part. So I'm going to talk a little bit more about some foundation use of Wireshark. All right, if you go to wireshark.org and then go straight to the download page, then you can see it there. You can download current stable release. They literally just released a new development version, but they're kind of calling it semi-stable. It's almost release candidate with some new features today. They come out with releases, you know, not super frequently, but new releases are always coming. There's a global development team working on different aspects and different dissectors, as it were, the protocol analysis piece. And even to the point of people write their own dissectors. Some share and some can't share because it's proprietary to where they are. The main Wireshark window here, there's a lot to it, a lot of bits and pieces. You're going to spend your time kind of looking for the packets initially. Find my little laser pointer here, looking at the kind of the packet listing, and then you start to see some packets of interest, and you get maybe the details of the packet kind of in the middle section here, and then you can finally get down to the bytes, what they call the bytes pane. I'm so very rarely there that I don't even keep that up into my view because it takes up real estate. But a number of different things you can potentially tell from just even a screenshot view. You can see these packets up here in the main packet list area. Different colors. You can use colorization as a way to help your eyeballs focus. And this is a lot. If you're looking at a live trace and the packets are just flying by, and you want to know of certain packets as they fly by, and yet if they're all the same basic color, black on white, or gray on black, or whatever the coloring you might have, it's much more difficult to see a packet of interest or a type of packets of interest. Apply colors to them, and now, like in that particular view, that's my IPv6 view. When I see red going, I know it's a certain packet. When I see pink going, I know it's a other certain packet. I expect them periodically to occur in a live trace. I expect to see them in a static trace file periodically, not necessarily on any specific frequency unless I'm actually troubleshooting that. And there's all kinds of other packets in here. We can see the varying types, and colors might help. You don't have to use colors. All right, I'm not going to say you must. You could. If you don't like colors, and I know people that don't like the colors, they find it more distracting, then don't use colors. It's literally a toggle button. Toggle it on, toggle it off, and then go create your own colors for what you might want to look at. Some of the other sections that we're going to just focus a little bit on here in just a couple of minutes. What's really hard to see up here, number 4, the display filter area. You can create filters to either focus on specific packet types or to remove certain packet types from your view, meaning I want to look for something specific. Are they occurring? Or I want to look for stuff, but there's some packets I don't need. Like a lot of times in work I'm doing at the network infrastructure level, I don't need to see spanning tree packets. I don't necessarily need to see link layer discovery protocol packets. I don't need to see some of that foundation traffic. I want to get it out of my field of vision altogether. So I can put a display filter in there that basically says, don't put them in my view here. It still is captured. I still have the data. I just don't need to see it right then and there. And I'm going to spend a lot of time on display filters because that's where I work a lot. Some of the other areas, especially down here at the very bottom, the status bar will tell you things like, if you see over here, this is a trace file, static trace file that I'm looking at, 2,767 bytes. I don't have any display filters, so I'm seeing all the packets. But as soon as I start putting in display filters, then I start to see, well, how much of this trace file is this type of packet? And I can start getting some kind of ideas. Also down here, this section called profile, I'm going to spend some time in there. I may want different views for different functions. Am I troubleshooting infrastructure? Am I troubleshooting protocols? Am I troubleshooting applications? I can build these profiles and then switch between them and get all the views and all the filters that I want instantly available, as opposed to having to always, quote, manually create my view and change my views. I can maneuver around these profiles really, really fast. So the color rules, use them if you want, set the colors to what helps for you. You can have all kinds of different of these color rules defined. They're pretty much like either ACLs or firewall rules. You build them, you put them in the order you want them to trigger. And if you even want them to trigger at all, you can set these up. One little tidbit here, you see ICMP is a default Wireshark, but it includes both V4 and V6 ICMP traffic. Well, for me, I wanted to know my V6 traffic in a different color from my V4. So I built this ICMP V6. I also put it higher in the list, so it triggers for V6 traffic first. So they can help. These display filters, most of my use of display filter is I want to see certain traffic. But there are times that I will do it just the opposite, get rid of some of the traffic, but still keep some things. So this is basically definitions, and these are the most recent, of looking at certain kinds of traffic. And if you kind of look at this pretty quick, it should be kind of easy to say, I want to look at, like this one that's selected up here. I want to look at DHCP-v6 or ICMP-v6. Doesn't matter. I just want all of that traffic. And this is, again, where we're going to play. Now, this is helpful if I know what the syntax and basically the coding definition is of a protocol. You know, I want to look at positive HTTP responses. Well, you got to dial this all in. And if you don't know that, then the next best thing to do is to grab some packets, find the packet of interest, go down into the packet details and do things like select a section, right click, apply this as a filter. So it creates that filter definition for you. You don't need to know the code, as it were. After a while, you'll start to understand that work. And you can build very complex, look for this, but not that, or this, and not that, and really dial in the viewing of what you're trying to use Wireshark for to see just what is important. We're talking saving some seconds to some minutes here. And in some modes, as they say, every second counts. So that's a little bit of what we're trying to do, is just make it a little bit easier of a tool to use. You got to spend a little time up front. It's like any other tool. Almost have to play with it every so often, but it might pay off down the road depending on what you're needing. One of the other things, and let me kind of go back a few slides, you know, if you look at this trace, we've got some column listing, and this is the effective default. But there may be certain components of a network, either a segment you're on, or there's a certain type of application running, where wouldn't it be really handy to have that information right up here as a column? So you can add columns almost as easy as you were doing these display filters by finding a packet, basically selecting a component down in the packet details and do the right click and add it as a column. And then you can go put that column wherever you might want it. I'm going to have some examples of adding columns in here as well. It by default puts them to the left of the info, which is basically on the far right side. And then you could just simply drag them around, rename them, resize them, the whole bit. I mentioned briefly about these configuration profiles. This is how you maneuver through your views. You can see just in that short little listing, I've got all kinds of different views. They mean and relate to projects. They could be customer projects if you're consulting into different places. If it's inside, say, an entity you work for, you could have these different profiles for the different kinds of use of either the infrastructure or what you need to be looking at. Are you troubleshooting or wanting to view certain applications? You could have a profile that would have your columns and your colors and your filters all where you want them. You're looking at network infrastructure. Even then, are you looking at edge or access layer? Are you looking at the middle distribution layer, or are you looking at core? Are you looking on the server nets? Are you looking on wireless networks? You know, where are you looking, and do they have different focus needs? Build these configuration profiles to kind of assist in getting those views the way you want them. And then it's literally, you go down to the bottom, you click on the arrow, you go select it, and everything reorients in your view. And I'll say immediately. Now, if you're looking at a very big trace file or an active trace, okay, it's got a few seconds that it processes, but generically, you can maneuver through these profiles really, really quick. Another feature that is really not so new anymore, but it was just the greatest, coolest feature at the time that came out like 6 years, 7 years, maybe 7 years or so ago, called packet comment. In the old days, as some of us might say, you'd get a trace file to basically from a troubleshooting routine, and I knew it wasn't a network problem, but everybody's blaming the network because that's the way it is. You know, if you're the network team, it's never the network. But you can't just say that because everybody says, look, it worked yesterday, it doesn't work today, things are running slow, it must be the network. And so now we go through, we troubleshoot it, and sure enough, we find it's an application problem, or it's a config in the application, or it's a problem on the server side, or wherever it is, not in the network. But you find these packets that lead you to believe to that conclusion, and or it is conclusively where you have know the problem is? Well, you could go in there, literally right click on a packet and give it some metadata, some text information. And now I can take that trace, send it over to the server team or the desktop team or the applications team or the security team, whoever kind of is responsible for where I think the problem really is, and say, fire up Wireshark, bring in this trace file, build a display filter for packet comments, and there's all the information where I've basically have found it's not the network, it's, quote, your problem to work through, because that's not my area. I don't have that accessibility. Or the other thing that I tell people from especially the network team, do you have traces of the good days, of the good times, when things are working, so that when you're troubleshooting, do you have something to compare what you're seeing now to what it should be? Most people look at me with the kind of like that deer in the headlights of, no, I don't. And it's like, why wouldn't you want to know what things should look like? How can you effectively troubleshoot if you don't know what it's supposed to look like? It's like the years that I was consulting, I would go in on a fire drill project, and okay, network team, I need to see a network diagram. Well, we don't really have a current one. What? What do you mean? Well, we got something that's a little old, and you get this piece of paper and it's all marked up in red ink, and you're trying to figure it out. It's like, forget it. I'll map it out with Wireshark. I'll figure it out looking at different points of presence in the network and figure it out, and then I can make comments to it and then have a better idea of what's going on. So it's metadata. It's preserved within the packet file, but it is basically optional type content that we have available via Wireshark. Here's an example. Oh, I found a rogue router advertisement, and you make whatever comments you want in here. I think the limit is either 256 or 512 characters. I remember I've looked it up, and I don't remember what it is because I don't get that verbose. Usually a little bit more succinct, but it doesn't mean that I don't want to know. Sometimes I don't get to that point and have it all out there. And it just dawned on me, team, I didn't bring up chat. I don't know where I can see chat here, because if you're sending chat messages, I'm not getting them offhand. Let me see if I can find that real quick. Video mute. Okay, so maybe Nick is going to monitor chat for me, because I'm not. Oh wait, there it is. I got it. My apologies, team. I forgot to bring that up. Okay, so fun things about Wireshark if we're going to have to use it. And here is a built-in display filter. It's called PKT_comment, packet comments. Build that, and then it just filters out all the packets that have a packet comment that somebody has made. This is the human's involvement, okay? You're not going to get this dynamically. It would be a way cool dissector if you discovered a packet then to automatically add a comment. Ooh. Nice, easy ways. At the old days, you would take the packet, you would mark down all the packet numbers with the issue, maybe go into the details, you compile an email with all that data, send it to the server team, and away you go. Now you can put it all in one place and have one source of data, one source of information. Now there's another type of filter. I myself don't use it a lot, and they're called a capture filter. If you're on a busy network segment and you're trying to grab everything, you could actually miss stuff, and it's not really even that hard to do. However, you may know from a quick regular open trace of what you kind of need to focus on. So then you could build a capture filter to basically say, okay, filter for only this and display this, or filter for this and make sure you don't get it to me. I don't want to see it. And it's not going to keep it in the trace file. So the capture filter is that what Wireshark is capturing and going to give you or not give you. And a display filter is whatever Wireshark has captured, you can filter it for specific components. So lots of people I know, they'll look at that and say, capture filters, use them all the time. And my general rule would be, first I'll capture with no capture filters, determine if there's traffic I don't need, and then maybe I'll build a capture filter so that I don't miss the important stuff. The syntax is a little different in using or configuring the capture filter, but still you've got some of the nice ways of being able to go through it. But my comments in both of these, if you put in a filter definition and you get green, that means Wireshark can do it. If it's red, Wireshark doesn't know what you want. If it's yellow, it might work, but there may be other stuff you need to put into that filter definition as well. Some of the other features that kind of follow into what some people call the expert level features, looking at like this particular one, top talkers. Fine, you've got 200 devices on a network segment. Who's talking the most? Depending on the kind of segment you're on. Are you on an access layer? Are you on an infrastructure layer? Are you on a server net? And again, you know, who's the busiest? May or may not provide some amount of information. It may mean if you're trying to troubleshoot a particular kind of problem, you want to go find those people, well, maybe not the people, the systems by address that are doing the most talking. You perhaps will be able to get the better information. Years ago, I was troubleshooting a problem where it was an intermittent a database integrity application. The problem occurred randomly. It didn't matter time of day, day of week, load, how many people. We could find no common denominator. And so we ended up with like half a dozen capture boxes all over the network. And finally, we got one. Top talkers wouldn't have necessarily helped, but at the time, it might have given us a little bit more data to work with, because it was a really interesting problem. And it turned out it was not a network problem. That was the best part. The application developers were actually going against some of the specs of TCP. Now, another one that I tend to use a lot more, though, is tell me all the basic protocol components that are running, i.e., I expect on a given network segment to see infrastructure protocols. I expect to see some application protocols, and I can do a real quick view after either getting a trace or looking at a trace file. Do I see some of the types of traffic that I expect? Or more importantly, do I see traffic that I wasn't expecting? Maybe I wasn't even looking for it. Maybe it's not supposed to be there traffic, okay? And it becomes all of that. Well, why is that traffic there? Now, naturally, you have to be careful of getting sidetracked, right, from the real problem, but it also could be something that you see at a large amount of traffic maybe is relating to the issue at hand. Unto itself may not be the problem, but it could be a factor in the problem. So really easy to get an idea of the traffic types that are on the network. Another handy feature is you can do these follow streams, TCP, UDP, and SSL streams. So instead of trying to look through all of the packets that make up go to a website, you can click on either the first one of that sequence or just pick one in a sequence and go do the follow the streams, and it will assemble all those packets and then give you exactly what we see here. It was a call to a website, and we get to see what was on that page. Now, in this particular case, very simple, very easy, but it's another way that could be handy in trying to troubleshoot and looking at even some of the coding of the application and go, oh, well, we're missing X, right? Or we're trying to call something that was not the right kind of call. You can see all this stuff in the packets on your own, but it's much harder because you got to go literally packet by packet of that sequence to get to this point, or you can do the follow the stream. Where do you capture? And this has been the question since forever. I've been doing packet capturing for 31 years. And it was no different then as it is now. Uh, most of the time, we are not set up to be capturing. So therefore, once we want to capture, we have to determine, can I capture on a machine, whether it's the client or a server um, system. Sometimes we can get to what we call the span or the mirrors of a switch or a switching router. Uh, the good news is it's pretty much available in any managed type device. The not so good is most people want to get more than just one port. They want to look at the uplink port. And the next thing you know, you're going to have too many packets. You're going to miss some packets. And sometimes it's even just part of that device, the infrastructure device's operation. Are they processing that in ASICs, or are they processing a span mirror in CPU? And if it's in CPU, you're probably not going to get every single packet. The other thing is most people don't have span mirror already set up, so they have to go configure that. Um, the other great thing would be to have what we call taps, which means you would have a device that looks like a mini switch sitting between either a computed device and a switch, or multiple switches. It's an infrastructure placement. Um, if it's there and all you need to do is connect the tool, Wireshark, up to it, great. If it's not there, you literally have to break a connection. In all of these cases, whether you run the application on a system, whether you do span mirror, or whether you do the tap, if you do anything at all that disrupts the, the operation, then you might inadvertently clear up the problem. All right. Ask anybody that is into network troubleshooting, you know, about that, because we've all experienced it. Even installing an application on the server did something, made some registry or some update to a file that the core system might use, and it cleared up the problem. And by the time you got the trace file, everything was working. And then all we get to say is, yay, fixed, done, next. All right. So there's not a great answer here. It's just one of the things that we have to be aware of. Okay, before we do that follow me demo, I want to show you a few things on my own, and then we'll do the follow me. So let me, let me bring up Wireshark. And there we go. So what I have is a big packet that I created literally last night by merging a bunch of other trace files, because I wanted all kinds of different protocols. So this is not the one you get to download, but I just want to show you a few things on this first. Okay. If we could kind of see in here, if you look down at the bottom, it's 346,000 packets. All right. I'm in my default profile. And that would be Wireshark out of the box, as I call it. You've installed Wireshark. This is the default view. All right. The first thing I want to do is actually go copy my profiles from my other computers. They're all portable. This is the great thing about this, is that once you get these profiles configured the way you like them, and your teammate looks over your shoulder, maybe virtually now, and says, oh, yeah, I need that profile. Then you go, fine. You literally go up to help, about Wireshark, go to folders, personal configuration, double click it, it opens the folder. Here's profiles, and I can go down here and I can take this folder that has the profile definition in it, the coloring, the filter buttons, etc., any other preferences information, and I can put that up on a shared drive. I can email that to my team, and now everybody, when I say, okay, we are looking at this trace file, bring up this profile, because you want everybody to see it exactly the way you do, and it's that easy to share them. And it doesn't matter if I was on a Windows computer and you were on a Mac. I can send you my profile and you bring it right in. So that's a really, really handy thing. And so I've got a lot of different profiles over here. I've got one that I configured for, I call it Wireshark hands-on. And so this is going to change my view, processing those packets. This didn't change a lot other than maybe you can see some of the font is a little bit smaller. Maybe I'll bump this up a little to kind of help it here. I've got some display filters where I didn't have these before. Um, this does have some of my color rules. You haven't seen it yet, but if I quickly scroll through this, look for red, look for pink. They should be in there somewhere. And I'm going a little fast, but that's kind of the whole part of it. All right. I haven't really seen that many red or pink yet. That was a red, but it was not the right color red. Well, I didn't really see it. I was going too fast. There's just not that many of them in there, but that's okay for now. You could kind of see some of that was going on. So with this particular view, we can see a couple of things. There are some V6 and some V4 traffic right off the bat. And that's a thing to know. In fact, I've got a couple display filters that say, just show me the V4 traffic. And once it processes that, look down in the lower right and I can see, well, 79% of these packets are V4 packets. And already we start to see no V6 traffic, no V6 packets. If I click on the V6 button up here, it resorts to looking for IPv6 protocol, and we find out that it's 18.3%. Well, now it's a lot easier. Oh, wait, did you see those couple of reds go by? All right, where'd they go? They still went by too fast, Jeff. Oh, there they were. Anyway, now see over on this right side, you got a color bar to also kind of help you say, oh, well, there's some reds. Well, now I can kind of click on the red area and I can find my reds. All right. So other colors in here as well. Some of them I can more clearly see, some of them I can't. But that's that filtering. I could just as easily type filter information up here, and you already saw, okay, you start typing IP. Well, here's all the IP options, all right, as you start to go through. You take it out and click on this blue right arrow button, and that's basically the resort. So if you make any change in the filters manually, you got to resort it. If you click on a different filter button, it automatically resorts to that. So you can see we had some V4, a lot of it, and some V6 traffic. I want to look at some of my other protocols that might be on here. Well, let's go back and look at that statistics and protocol hierarchy and say, well, hello, there we are. What protocols do we have? Here's V6, and here's all the V6 related protocols. There's V4 and all the V4 related protocols, a few more in there, right? And then we have some other protocols in addition to just V4 and V6. You got link layer protocols. We've got some 802.1ad. We've got some 802.1q. VLAN protocol here going on. So there's all kinds of different things running around on this network. And that becomes a bit of powerful knowledge, especially if I want to do what I will call some type of targeted viewing, okay? And there's a big wink wink going on with that, targeted viewing. Okay, we saw some things in there. Let's look and see if there's any packet comments anywhere. And, well, sure, there's a few packets, 18 to be exact, packets that have variant comments. We could look at this and say, you know, there was a telnet session that started, and I actually made some milestones of the different packets and what was going on at those particular stages. All right, router advertisement, what was going on with that? Link layer multicast name resolution, or link local, not link layer, link layer, kind of a V6 DNS. So those were just the packets that had some comments, okay, that's in here. So we can get rid of that filter and it'll refilter back. Telnet. Telnet is a great thing because it's, you know, typically either an infrastructure protocol for management, or it's being used to access systems, Linux systems more typically, I think. And we love Telnet because it's clear text, and everybody forgets that. Well, it's clear text, and all you got to do is step through the packets. Well, remember that follow streams? Let's just go up here and analyze follow the TCP stream related to that packet that I clicked on, all the ones that might relate to it. Well, now I get to see what was really going on. Oh, we were accessing a Viata box, and there's its host name, and there's its clear text password. Right now, of course, one would never use a clear text password in a production system. Oh, by the way, I forgot my disclaimer. Please remember, if you are capturing, have permission, have written permission, have it very clearly defined where you can be and what traffic you can get. Remember that you may get traffic not for your eyeballs. It used to be the infrastructure team, it didn't matter. But now with data privacy rules and not protocols, what's the other thing? Let's just leave it, data privacy rules, regulations, that's the word I'm looking for. I may not be allowed to be capturing traffic on an HR network where I could see personal information, because I've got the keys to the kingdom. And of course, somebody's going to follow up and say, oh, well, it's encrypted traffic. Yeah, that just slows us down, right? It does not mean it's going to be completely hidden. So that's why I'm showing my telnet little thing here. But we can see what went on. We executed a login to this device. We did a show config. Oh, lovely. I get the full config information here through a trace file. I don't need to log into the box now. I just need this particular trace file. And then I can take it. Yeah, I'm going to have to do a little cleanup. But you know what? That was a lot easier than everything else that I was trying to do. So we love Telnet as opposed to, right, SSH. Because now my SSH traffic is going to be all encrypted. And sure, I can do, whoops, analyze, follow the TCP stream, and it's virtually going to be garbage. All right, I can start to see a few things with it. I know maybe what I've got access to. I know there's, you know, header information, but past that, I've got no payload data whatsoever that I can, quote, clearly read. All right. There is the capability in Wireshark to enter in SSL keys or certificate. You can enter in SNMP v3 encryption IDs. They do not have the capability of putting in the public keys for SSH. I mentioned it to a developer last year, and there's a yearly conference, it's now virtual, called SharkFest. And it's basically the developer and user kind of a conference. And so I mentioned it to a couple of folks. They pointed me to the developer that works on that kind of security protocol decoding. And he's like, yeah, I've had a few requests for SSH being able to put in the private keys, but I haven't done it yet, you know, and all of this is voluntary. So if it happens, it happens. If it doesn't, it doesn't. So we can't decode SSH yet, but who knows, maybe someday. But you start working to this degree of saying, well, out of the overall 346,000 plus packets, 96 of, well, in this view, let me redo that to all the SSH. All the SSH packets, still 2,363 of the packets are SSH packets. Not a lot of SSH traffic going on here. Doesn't necessarily tell me any other information, but just that. But at least can be looking for certain pairs. You know, if I have an idea of who should be talking or who I expect to be talking, well, then I can build filters. Let's just say, let's look at one of these. If we knew if 187 was a server and 29 was a client, then we could say, well, who do I want to look for? Well, I happen to know that 29 is the client. So let's look at 29 from a source perspective, all right? Source column, and come down here, open up the decode, go down in here to the, where did it go? Source field, right click, apply as a filter and say, all I want to see right now are any packets that are SSH and the source being .29. So I do this and select it. I've already got SSH up there, so I need to add and this host. And it's going to resort and give me just those packets that are sourced from 29 to wherever 29 is talking to. And it turns out 29 is only talking to 187. But that's okay. That was how quick I could start narrowing down that field, and now I'm down to 952 packets with probably not much else I'm going to be able to see here because it's encrypted. But hopefully these start to give you these kind of ideas of what you can do. All right, other protocols that are up here. We also discovered there was HTTP. I don't have a decode for that. Well, no matter. All I got to do is type HTTP. My bar went green. And let's resort and find all of the web traffic. And we can see there's 2,400 packets down here that are HTTP traffic. And we can look through, maybe start to see things like, remember, click on one of these gets, analyze, follow the stream. And it's going to find all the packets relate to it and give us whatever that represented. Not a lot, but nonetheless, we get to see that. Now, because I don't have that HTTP filter in my view, let me go back to just HTTP. I can simply say, let's add that to my display filter button bar. Click on this plus here. I'm going to call it HTTP, and it will add it to the right, and now it's in my button bar. So now I could be over, let's go back, let's just pick radius for 1. And then go, oh, that's right, I need to look at something in HTTP. Click back on it now. And it's in this profile. So I'll have it there. If I leave this profile and go to something else, some other profile, we'll let the packets resort and go back to hands-on, then we can see that. You can see some of these views. I've got another one here I'll show you real quick. VLAN, and I'll have some different columns in here. I'll have VLAN, VXLAN columns in here, and then I can even see my buttons changed. And let's look at, is there any VLAN packets in this trace file, this big trace file? Well, sure enough. And because I've put some columns in here, I can see, well, there's some VLAN 10 and VLAN 30, and who knows what other VLANs? Well, I can just click on that column and resort numerically and find out there's VLAN 10 packets. Uh-oh, let go. He's sorting and he's locked. The bad thing about a demo, hopefully we're still going, oh, he freed up. Okay, so now we got him in order. There's some 10s, there's some 20s, there's some 30s, and that might be it. Let's go back to that hands-on. Now everything goes back to where it was, except for my display filter still stays, but that's okay. That's how quick and easy this is. All right, let's do that follow me. So bring back up the PowerPoint. All right, you're gonna open up, if you've got it, the workshop, follow Jeff, and we'll just look at a few of these protocols just like I've been doing. So let me open that trace file up. Where do I have that trace file? Follow Jeff. And, oh, I got to get rid of that display filter. There's none of the VLAN packets. Sorry. So here we are. This trace file, a lot smaller, 3200. Let's do some things. Let's like type in telnet up here. All right, just to kind of have fun. Type telnet in there and find out all your telnet traffic. Same thing again. Click on the first packet you see of telnet. Go to analyze, follow TCP stream. We can see here I'm logging into, looks like an HP switch. We can decode in here the username. Now it gets a little fun, but here is the letters M, A, N, and at the end you're going to get manager was the username, and then password was the password. And then I did a show telnet was the command I executed. Again, you have to kind of decode it all in here, and it showed me my active sessions into this particular device. And then over here somewhere I did a log out. So not always is it going to be so pretty English for the human eyeballs here. You may have to do a little bit, but if you can even see either in my view or your own view, these letters that are highlighted in a different color, that was the key press entry. All right, so that this down in this section was a log out. You're presented with the question, do you want to log out? And then there was the answer. There's a Y in here somewhere that's kind of in red. Oh, there it is. Yes, I wanted to log out. What other protocols we were saying? SSH. Let's look at DNS. I haven't showed anything DNS quite yet. All right, same thing. Go up here into the toolbar and just simply type DNS. Now, one thing to understand about Wireshark is if you type in protocol names, you may get more than what you expected because DNS is multifaceted. What that translates to is there's a number of different protocols that relate to DNS. It may not be just UDP and TCP 53. There's 55 or 55, 53, I think, and another one. How do we know this? We can go to edit, go to preferences, we go to protocols, and down in here, let's go find DNS. And we can see that Wireshark is going to pull out 53 on TCP and UDP and 5353, I was incorrect earlier, for TCP. So any traffic with these three protocol types is what that DNS filter relates to. You can change these, or you could make your own if you particularly wanted. You got to be careful in some application protocols because is it UDP? Is it TCP? Could it be both? Like DNS can be both. So there you have that. So somebody was asking for the URL. I'll get that real quick here. Give me just a minute. I'll drop it in chat. All right. There is where you can get the trace file from. Trace file, yeah. Okay, so there's, you know, another quick little view. Oh wait, I don't have DNS up here in my Wireshark hands-on. Let's create the DNS shortcut filter. It's so hard for me to type these. I must have these shortcuts, but now it's there, and it's up here in the bar. As you add more, this filter area shrinks to, it finally will go to only about 2 inches wide, or not too far, not too wide, when you'll have a lot of different filter names up here. Okay, so that was a couple of things we were looking at from the trace files. Capture, all right. Some of the other things I was talking about that you can do is like, well, let's build a complex filter, all right. Looking at, I want to look at a DNS query going to this URL. So I'm going to go ahead and just copy this from here. And I'm going to go into Wireshark and type it in just like that. Hit the sort button, and we find out there it is. There's all the traffic in this 3200 byte or 3200 packet trace file that was related to www.ipv6sandbox.com. And look at this, even more fun, it is V6 traffic. And oh, by the way, not only is it V6 traffic, but it's V6 traffic asking for V6 and V4 queries. So it's looking for, well, if you've got the answer in an A record, I'd really like that, all right? But that's a V6 protocol. Yes, it is. V6 and V4 in DNS now ask their questions in both ways. Give me an AREC or give me a quad AREC resolve, please. The first one it gets, based on the protocol it can operate on, will work. So that becomes how easy you can start to use some of this power of this protocol analyzer, protocol decoder. There are others out there. There are other free ones out there. There are others that cost money that may or may not have some varying different features. But if you want to understand something about Wireshark, just go search it in your favorite search engine. All right. Somebody either has had the answer, or you can go to the Wireshark site and post a question. Somebody will assist. If you need a custom decode, you can put the query out there. Somebody may build it for you. There's no guarantees. It's all open source, but it is a very handy community. I had another trace file here that you could do the same kind of thing, this 201 trace. And let's bring that up and maybe a couple of these other protocols we haven't looked at yet. So let's open that 201 file. And let's get rid of that current filter. And I want to search for TFTP traffic. Nice thing about TFTP, it's open. It's clear text, right? So you can already see some of the information in clear text down in the payload. And I could even potentially click on the first packet, go to Analyze, follow the UDP stream. We don't get the same kind of information on TFTP from that packet, but we get to see things like, well, here is the name of a config file that was probably being transferred. You might be able to ascertain from this some information, okay? Really, really handy, or something that is still meaningful. So let's go back to all the TFTP traffic. But I potentially could follow it and find some information. I can start to even see here in this part of the trace what I would say configuration information. Let's see if we get any more in the analyze. Do you always get everything looking at the streams? No, but if you get the right packet like this one, there's the config. All right. All kinds of great information, again, that's here. And not only that, I could pretty much take this one and literally copy and paste it, right? Put it into Notepad and pipe that straight into one of those devices, a VIOS router. Now, I may have to go through and do a little cleanup, but again, I've got a lot of the information right there. So with that, those trace files and with Wireshark, you could sit there and play, look at the packets, get some practice, turn on Wireshark on your own computer and just look at an interface, all right? If you've got multiple interfaces, pick one, you know, whatever you're gonna see. Now again, if you're on somebody else's network, make sure you've got all the clearances to be capturing their traffic. If you don't believe that that's important these days, search back for that incident that happened last year where a couple of guys were out doing supposedly a valid recon and were arrested and thrown in jail for a couple of more days than a couple of days while it was all being sorted out. They thought they had their get out of jail free card, and turned out they kind of sort of didn't have it from the right source. Another one here, and I'm out of time, but I'll just kind of show it to you. I can go into an HTTP packet, go to a certain offset, in this case where the user agent information is, and look at so many bytes at that offset to determine what the host OS is. So if I grab this and take it in over here and pipe it in, so I want to go to the area, all right? I don't want to go to just the HTTP part of the packet. I want to already get myself down to the user agent area, all right? That's what this filter is talking about. Go to the 24th byte after that area starts, and then look for the next 4 bytes and see if you can match that 4-byte string. And if you do, I should find out in there what version of operating system I'm running. And it turns out that if you count all the offset over, it's Windows NT 10, which translates to Windows 10. And then I can see more. Now, I could have potentially seen that with just HTTP traffic, right? But look at that. Well, I've got 8 packets. Well, okay, fine. 8's not a lot in this trace file. And I might be able to, now that I've seen that, do I have different OSs? And so, oh, well, there's a WinNT 6.1. I think is that Windows 7? I honestly don't remember. Another 6.1. There's a 10. So you kind of get the idea. Another part of the power here is that once you got this packet, you don't necessarily have to just search for high-level protocol definitions. You can search down to a bit if you know an offset. The offset could be from the very beginning of the packet, or the better, perhaps more concise way is to take you down to a sub-level, to as close as you can to the area that you want to search on, and then do that same kind of thing with the offset. In this case, go in 24 bytes, go to the 4th byte. Sometimes it takes a while to create these and to work out the math and really get it dialed in. But oh my goodness, how much faster if you knew exactly what you're looking for, you know where it should live because it always lives in the same place, then you can start to dial in the use of Wireshark. I'm out of time. I could go on forever and ever, which is generally the problem, but I hope this gave you some thinking ideas. Again, Wireshark can be your friend depending on what you're doing. And sometimes it can give you information that's not exactly related, but if you're on some kind of a recon project, whether that's looking for problem areas, whether you're trying to look for some security related, you're trying to discover kind of what's going on in the network, whatever it might be, you might be able to use Wireshark to help give you the information to at least point you in a direction. Again, sometimes it's just as simply to say, what's not causing me the problem? And then go from there. And or at least be able to bring in other team members to say, okay, I'm not a network person, network team. Look at this trace that I'm getting or that I've got and see if you see anything wrong for your typical areas. And then over time, you might get a little bit more experience and a little bit more comfortable with it. Don't be afraid and ask questions out on the world, even in Twitter. I mean, if you follow any of this stuff, people are daily talking about these kinds of things. Well, at least daily with the group that I hang around with. Any other last questions that y'all might have? I know it was fast, but I hope it gave you some ideas. We could do more in depth. We could do a different focus if y'all ever want to just get a hold of, I guess, Nick and Ray or pose the questions back into their forum and we go from there. Thank you again for your time and let me come in and talk. This is one of my favorite subjects. I have a lot of fun with it. I am in Wireshark, I would say almost every day. It may not be for long, but I'm looking at something. I was working on a project last week and somebody said to me, I said, well, what does the package say? And they're like, I don't know. I haven't looked at it. We go to the packets. No wonder things weren't working. Nothing was being sent. It was a misconfiguration in one of the routers. And so therefore nothing was being sent. And that was the why. So, all right, team, looks like we're all done. Thank you very much again. Everybody have a great rest of your day, probably evening. And the week is now a little shorter. Enjoy your week. Stay safe, everybody. Thanks
All
again.
right, Jeff. Thanks for coming out. Really appreciate seeing you here again. We can't wait to have you back.
Well, I look forward to it anytime. Thank you very much.
All right, bye.
All right, bye-bye.